All right, let's take a look at an example of a non-standard normal distribution case. Okay, so let's take a look at this problem here, heights of women. In a survey of U.S. women, the heights in the 20 through 29 age group were normally distributed with a mean of 64.2 and a standard deviation of 2.9. Find the probability that a randomly selected study participant has a height that is less than 56.5, between 61 and 67, and more than 70.5 inches. Okay, and then the last part, identify any unusual events. Okay, so one of the first things you need to recognize, and especially when these problems are all jumbled up on a test, is that while they say this is normally distributed, it is not standard normal. So you're going to have to remember to, if you want to do this by hand, to standardize the x value, okay? Or if you're using the calculator, you're going to have to overwrite mu and sigma. Okay, so we're given a normal distribution with mu is equal to 64.2 and sigma is equal to 2.9. Okay, so one thing to realize, this is not standard normal. Okay, so for part A, we want to find the probability that a randomly selected woman is less than 56.5 inches. So that's, in probability notation, that's the probability x is less than 56.5. Now I can't use the letter z here because I haven't standardized yet. Okay, so to use the table, we have to standardize. In other words, we have to convert to a z-score. Okay. Now I am perfectly fine with you using technology. Okay, I'm just showing you this process. I'll just do it for part A. Okay, so to do that, I want to convert this x value to a z-score. That's the same thing as saying probability z is less than 56.5 minus 64.2 over 2.9. Remember, the z-score formula is your x value or your observation minus the mean divided by the standard deviation. Okay, so let me get that z-score real quick in the calculator. Okay, so rounding to 2 decimal places, because that's how far our table goes, this z-score is negative 2.66. Now, remember in Chapter 2 when we first talked about z-scores, anything below negative 2 or above positive 2 was considered an unusual score. So this is an unusual score in terms of a z-score. But now we need to find the probability, because what is considered unusual in terms of probability is having a probability that's less than 0.05. Okay? So drawing a little bell curve, putting 0 in the middle. Okay, I want to shade a lower tail. I have negative 2.66. And looking at the table, that area is about 0.0039. Okay, so yes, since this is less than 0.05, this is considered unusual. Okay, now let's do this one in the calculator. We don't have to standardize if we tell the calculator what mu and sigma are. Okay, so if I go to my distribution menu and select normal CDF, again my lower bound is really, really small. My upper bound, going back to an x value, was 56.6 because that was the height that was given. Now this is not a z-score, so I have to overwrite mu and sigma. Okay, 64.2 for mu and 2.9 for sigma. Okay, so this answer is about the same as we got from the standard normal table. If you were to do this on the older calculator, you would open up your normal CDF, you put a lower bound of a really small number, upper bound, in this case, would be negative 2.66, and then you have to tell it mu and sigma. Okay? If we're working with standard normal, you would close your parentheses after here, after the upper bound. Okay, so what makes this nice is we don't even have to convert to a z-score if we tell the calculator what mu and sigma is. Okay, let's take a look at part B. Between 61 and 67, okay, so that's the probability x is between 61, x is greater than 61, and less than 67. Okay, on a non-standard normal distribution, for this one, the mean was given to be 64.2. Sorry, that was crooked. So I'm finding an area from 61 up to about 67. Okay? So I could convert to a z-score like I did in part A, but I'd have to do the two endpoints. So this would be 67 minus 64.2 divided by 2.9, and then this z-score would be 61 minus 64.2 over 2.9. Okay, but what is happening is that this area remains the same. When you convert to a z-score, that doesn't change the area. Okay, so for a compound inequality like this, you'd have to convert both endpoints. Okay, but I'm not going to do that. You certainly could do that. Convert those endpoints, use the standard normal table. But I'm going to go ahead and use the calculator. Okay, so I'm going to go back to my normal CDF. This time my lower bound is 61. My upper bound is 67. And on this calculator, it's retained my mu and sigma. Okay, so about almost 70% of the values fall between these two. Okay, so this is about 0.698. Okay, and then you'd round however you needed to for MyStatLab. All right, so last but not least, let's see, part C, more than 75 inches. Okay, more than 75 inches, that's the probability x is greater than 70.5. Okay, so probability x is greater than 70.5. We're well above the mean of 64.2. We are up in this upper tail. Okay. Now, I could convert to a z-score just out of curiosity to see if this is an unusual z-score. Okay, this is 70.5 minus 64.2 over 2.9. Okay, so that's the probability z is greater than 2.17. Okay, so again, this is an unusual z-score using the criteria from Chapter 2. Let's see if this area is also considered to be unusual. Okay, so I want to know, is this area less than 0.05? Okay, so I'm going to go ahead and use my normal CDF. My lower bound now is 70.5. My upper bound, 70.5. My upper bound is a really, really large number, okay? Because I'm going from my point to positive infinity. Okay, so I'm going to put in an extremely large number and leave mu and sigma the same. Okay, so I get a value of about 0.0149. So yeah, this is considered unusual also because it has a probability that's less than 0.05. So I hope this helps you working the section. And if you have any questions, please feel free to shoot me an email.